All right, taking a look at your opener here. It says find your value of x. So we've done problems like this before. You've seen them in previous years where you're looking to see, okay, well, what am I doing to my figure? To get from 2 to 6, I'm multiplying by 3. So you get from 3 to x, I have to multiply by 3, and we get x equal 9. While yes, that does work in these basic problems, we also need to be able to create our proportions and work with them in case we get this problem that maybe becomes a little bit harder. Maybe I make this a 3x and this becomes a 2x plus 1. Right? Then you need a process to go through. And this is where in 6.2 we worked on creating those proportions. Right? Compare 2 to 6. If I compare 2 to 6, I also have to compare 3 to, or I'm sorry, in this case 3x, or we can go back to the old problem now. We can do 3. Then I have to compare 3 to x. And then we create that proportion so that we can cross multiply. But make sure you know how to create that proportion and solve it in case we do make this a little more complicated and make this a 3x and this becomes a 2x plus 1. Right? Then we really do need to make sure that we can create that proportion and cross multiply to solve. What we're going to be looking at here in 6.3 are what are known as similar polygons. Similar polygons are polygons that have corresponding angles that are congruent. So just like congruent figures, these corresponding angles are going to be congruent. However, your sides are not. Instead, these corresponding sides are going to be what we call proportional, meaning their ratios will reduce to the same thing. So let's take a look at example 1. It says, use your similarity statements to answer the following. It says, in your diagram, triangle ABC is similar to triangle DEF. So just like a congruency statement, we're going to be able to use this to figure out what pieces match up. Right? The difference is now they are not congruent. They get rid of that little equal sign that's underneath, and it's now known to be similar. Angle A will still be congruent to angle D because they're in the same spot. Angle B will be congruent to angle E because they're in the same spot. And angle C will be congruent to angle F because they are in the same spot in that similarity statement. Now, this next two parts, we're kind of going to do them together at the same time. And what it says is to check that the ratios of the corresponding lengths are equal. Right? And then we're going to write these ratios of your corresponding side lengths in what they call a statement of proportionality. So let's work on the first two first. AB compared to DE. Our statement of proportionality is going to look at exactly that. AB over DE. Well, if we look at AB over DE, that is 10 over 15, which reduces to 2 to 3. If I look at the next set, we are going to look at BC compared to EF. So BC was 8, EF was 12. If we reduce it, we get 2/3. Finally, we'll look at our last set, the set we're missing. AC, first to third, DF, first to third. Which would be 12 over 18, which also reduces to 2 to third. So it says check that the ratios of those corresponding lengths are equal. They are. Now, since they are, what your statement of proportionality actually says is that these ratios are all equal to each other. So we just put the equal sign in between them. Right? Same thing for your next one here then. It says in your diagram, triangle RST is similar to triangle XYZ. So we do angle R is equal to angle X. Angle S is equal to angle Y. And angle T is equal to angle Z. Now we have to use a similarity statement. Remember, just because an angle or a side's on the bottom doesn't mean it's going to match another side on the bottom. We have to truly use our statement. RS over XY. RS is 20. XY was 12. 20 over 12 reduces to 5 over 3. ST over YZ, which would give us 30. Oops, sorry, didn't go there. Which would give us 30 over 18, which reduces to 5 over 3. Then looking at our last set, R to T over X to Z, which is 25 over 15, which also reduces to 5 over 3. Since your ratios are equal, we create this statement of proportionality. And that's what that is. That's what it would look like. All right, take a look at example 2 then. It says quadrilateral ABCD is similar to quadrilateral JKLM. First off, it says determine whether the polygons are similar. So we got to first look at our angles. We have angle A is congruent to angle J. Angle B is congruent to angle K. Angle C is congruent to angle L. And angle D is congruent to angle M. So we have the angles working. Then we got to look at our sides. We have the side 8 over 14. That's AB over JK. So we have AB over JK was 8 over 14, which reduces to 4/7. We have BC over KL, which is 8 over 14, which also reduces to 4 over 7. We have CD over LM, which also is 8 over 14, which also reduces to 4 over 7 then. And then my last set, we have DA over MJ, which would give you 12 over 21, which also reduces to 4 over 7. So are your two figures similar? We have the corresponding sides being congruent. The corresponding angles being congruent, and the corresponding sides being what they call proportional, since they reduce to the same thing. So are they similar? Similar? Yes, they are. If they are similar, write a similarity statement. This is where I'm going to go to my angles and use them. So if I name my first one quadrilateral, we can name it, let's start at B. If I name it quadrilateral BCDA, then it is going to be similar to quadrilateral. Then I got to start at K. KLMJ. Right, you can put it in whatever order you want. Now the last thing is it wants a scale factor. It wants a scale factor. In these problems, it hasn't mattered what figure we put on top. Right? We did 8 over 14. And that's fine until we get into when they actually give the order that they want. Now it says, what is the scale factor of ABCD to JKLM? Which means ABCD has to come first. So notice that is the values that were on top. So our top value has to come first. So we're going to say 4 to 7. That scale factor is that ratio of your sides, just reduced. Right, let's take a look at your next one. It says, in your diagram, BCD is similar to triangle RST. Find the value of x. Well, BC over RS is 12 over 24. CD over ST is 13 over x. I have BD over RT is 5 over 10. All three of these ratios have to be equal to each other. The nice thing here is you get to pick any two you want to be equal. So let's pick the second two. We'll look at these two here. 5 times x is 5x. 13 times 10 is 130. Right? So then to solve our equation, all we are going to do is divide. 130 divided by 5 tells me x is 26. Right, this leads into our second part then of today. Talks about the perimeters of our figures. If I look back at this example we just did, when I look at the perimeters here, my scale factor right now, when we look, taking 5 to 10, we're multiplying by 2. If you look at your perimeters also, the perimeter of our first figure, add up all your sides, we get a perimeter of 30. The perimeter of our second figure, add up all your sides, we get a perimeter of 60. The perimeters of your figures will have the same exact scale factor as your sides. It says if two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding sides. So if I look at my first triangle here, if my perimeter is 12 and I have a scale factor of 1 to 2, then my bigger figure that we are creating will now have a perimeter of 24. Even though I may not know any of the sides, I do know what that perimeter would be. Take a look at example 4 then. It says a larger cement court is being poured for a basketball hoop in place of a smaller one. The court will be, so my new court will be 20 feet wide and 25 feet long. Obviously my figure is not drawn to scale, but that's okay. We're just using it to compare things. It says the old court was similar in shape, but only 16 feet wide. The key is, no matter what you're talking about, wide and long, make sure you put them in the same place. 20 feet wide, well, I put that on the bottom. The old court was 16 feet wide, so that had to go on the bottom too. It says, what is the scale factor of the new court to the old court? So to find scale factor, we just need two pieces that we know. Our scale factor here, it says new court to old court. So that is 20 feet to 16 feet. And then just like we do with all scale factors, we reduce. So when we reduce this, we get 5 to 4. Next thing then is what is the perimeter of the new court and the old court? Well, the perimeter of my new court, I just add up my sides. 20 plus 25 plus 20 plus 25. So we get a perimeter of the new court the perimeter of my new court is 90 feet. To find the perimeter of our old court, this is where we're going to set up our proportion. We have our scale factor. The scale factor is 5 to 4. That was new to old. We know the perimeter of our new is 90. What we don't know is the perimeter of our old. Remember, the perimeters will have the same scale factor as your sides. So our proportion, we get 5x equals 360. And then we just divide both sides by 5. And we get that new perimeter then. Whoops. My new perimeter is 72. So the new perimeter, the old perimeter was 72. The scale factor was 5:4. The perimeter of my new was 90 feet. The perimeter of the old is 72. Take a look at B then. It says, Mr. Carter is constructing a rectangular playground. The old playground has a length of 25 meters and a width of 15 meters. The new playground will be similar in shape, but only 10 meters in length. Once again, it's all about putting pieces where they match up. I did the length of 25 meters on the bottom, so that's my length. That means that my length that is 10 meters also has to go on the bottom. First question, you find your scale factor. My two sides that match up, and they want the scale factor new to old. So I do the new is 10. The old is 25. So my scale factor is 2 to 5 if you reduce. So there's your scale factor. Then it wants the perimeter of the new playground and the old playground. Well, we can find the perimeter of the old playground. 25 plus 15 plus 25 plus 15. So we get the old playground. Our old playground gets a perimeter of 90 meters. As for the new playground, this is where we need to use our scale factor. That scale factor was 2 to 5. And that was new, old. So the new playground, we do not know its perimeter. But the old playground had a perimeter of 90. Once again, we'll cross multiply. 5 times x is 5x. 2 times 90 is 180. And then we'll divide to get our answer. 180 divided by 5 gives us x to be 36. So that means our new playground has a perimeter of 36 meters. All right, brings us to our last idea. We talk about the scale factor here being the same as our perimeters, being the same as our sides. That goes actually for any length you could possibly do. If two polygons are similar, then the ratio of any two corresponding lengths, an altitude, a median, a side length, a width, a length, right? Perimeter, any linear length will have that same ratio. And that's what we're going to look at here in our last example. All right, so one of the things I will advise you to do sometimes is if you're having trouble matching up pieces, is separate your two triangles out. Right? They give us that small triangle on the top, triangle GJK, and then we have our big triangle, which is triangle GFH. They tell us that G to point M is 14. They want us to find G to L. So that's our X. Right? So just like our side lengths, we can use side lengths and altitudes in the same problem. When we go to do that, our ratio of our side lengths are 10 to 16. The ratio of our altitudes are 14 to X. And once again, we'll go through and cross multiply. 10 times X is 10X. 16 times 14 gives us 224. So when we divide by 10, we get X to equal 22.4. And our X, that was the length of GL. Right, here you have your homework. Please let me know if you have any questions.